Hello, welcome back to Module 3. So we are still in the analysis of statically determinate trusses. So we will now proceed with Unit 2, which is another method of analyzing determinate trusses. So in your Unit 1, Module 3, still, we discuss about the method of joints. So we use the method of joints by satisfying the equilibrium in each of the joints to calculate and to analyze, of course, the forces of member forces of the determinate trusses. So in this method, we will now be considering what we call a section. So in this discussion, we are going to solve the same thing, just like Unit 1, member forces of determinate trusses by method of sections. Okay, so instead of method of joints, we will now be using the method of sections. So we will be solving. Okay, let's try to solve the same example for us to compare the result with the previous solution, which is using the method of joints. So the solution of the reaction, please refer to this previous unit, the Unit 1, okay, since I presented there the solution of solving the reaction. So we ended up before into the vertical reaction at E to be 105 kips, and then the horizontal at that support to be 320 kips going to the left. And then, of course, if you will summate horizontal, that will be countered by a reaction support at the support reaction at the A, which is 320 kips to the right. So again, the solution is presented in the previous unit. So please refer to that solution. So now, once we have already the reaction, all we need to do now is transfer this one into the system or the truss itself, and then distribute this one into the members, and then we will be having what we call as the member forces. So in sections, okay, so if we say section, we are going to cut. Okay, in joints, we are going to consider joints by joints, but in here we are going to cut at a plane and then consider it's either the right side or the left side. So just like on the shear and moment diagram, okay, if you recall the shear and moment diagram, you can cut at a certain section, consider the left or right, that will give you the same thing, since we are considering this truss or this system as a whole. Okay, so if you will try, okay, these methods is, of course, requires the keen observation, okay, your keen observation for you to decide if that section will give you an unknown, or you will be able to solve an unknown from that section, because actually we can cut in a lot of possible planes in here. However, in some cases, in a lot of cases here, if I will cut, let's say in here, there will be 1, 2, 3. Okay? By the way, if you will cut, you will expose the member forces. Just like, of course, analyzing simple structures before in your mechanics. So if I will cut, then as again, if we will try to go back on the assumption of trusses, trusses are purely tension and compression. There are no shear. There are no horizontal shear. I mean, there are no member shear and there are no moments. Since there is no member shear, then there will be no member moments. So what we have there is only, it's either pure tension or pure compression. So if I will cut, you will expose now the tension or the compression member forces. Okay, so as I've said, there are a lot of possibilities. Let's say I will cut somewhere here, I will be exposing 1, 2, 3. And is that solvable? Yes, maybe. Okay, yes, we can solve 3 unknowns, given that we have 3 available. By the way, in method of joints, we have only 2 available, summation of forces vertical and horizontal, but in sections, we can now include the summation of moment to calculate forces or member forces. So yes, you can do that. Okay, you can cut somewhere there, that will give you 3. So we can use the 3 equations of equilibrium. If you will cut, how about if I will cut along this plane? Okay, so I will be cutting 1, 2, 3, 4. Okay, by means of the 4 unknowns, then I cannot actually solve that one, since we are only using 3 equations of equilibrium. So again, we will be cutting the this truss into a section wherein we can solve something. So for my solution, I will present this in a way that I will try to move from the right to the left. Okay, since again this is how I will present this one, but actually you can start anywhere as long as you can solve some of the member forces. Okay, so in here I will consider section 1, 1. Okay, so this is the section 1, 1. By the way, the arrow is pointing this way, so I will be considering the right side, since actually there are 2 sides if you will cut, the right side and the left side. So I will consider the right side, and then later on I will proceed with Okay, look at this. If I will cut here, I will be solving this member and that member. Okay, two unknowns, and we have three available equations. So that's possible. And then if that is already known, I will now cut this plane, and then this is already solved from the first section. So now left us 1, 2. Two more unknowns in this section. So we can do that. Okay, so that is the procedure. I will be moving from right to left. Okay, up to the time we will reach the final or the last member here, which is your AE. So section 1, I will consider this side, which is the right side. So I will transfer that one. So it seems like this is just like a method of joins, but okay, that is only happened because it so happened that there are no other connected members. Okay, so if that is the case, again, my assumption here will always be tension. My initial assumption will always be tension. If the answer will give me a negative, that means it will now become a compression. The correct will be compression. Okay, so this one, so you will now expose your HI, IH, and then ID, and then you will include that 15, that is at joint I. So if I will submit forces vertical going up positive, the by the way, the slopes the same, just like again our solution previously. So going down, this is a negative 15, and going down, the component of this is going down, so 3/5 of ID, negative also. So by means of simple algebra, this will now become ID is equal to negative 25. So negative 25, that means we are going to reverse that one. ID instead of tension will be actually a compression force. So DI is equal to ID, which is 25, keeps compression. Okay, and since that is compression, we need to indicate that one if we will be using this member on the next section. However, we need to solve that one. So summate horizontally, going to the right is positive, this will now be going to the left, so negative, and so with the component of this negative. So they are both negative, and the component of that is 4/5. Okay, since we already solved DI or ID, that is to be used there. By the way, in here, I solved this to be negative in this preliminary assumption. So if, again, as I've said, if you change the direction based on the sign, if you corrected this one, and then you will be using the figure again for the next solution, you will be carrying the positive since you already corrected. But if you did not correct it here, this direction, just like what I'm doing right now, okay, I did not change this one. Okay, I will just be following the preliminary assumption that that is tension. But of course, I already know that that is compression. Therefore, I will still follow the direction, but this time I will be carrying the sign, which is a negative. Okay, so that should be clear by now. That happened more than twice, I think, on our previous solution. Okay, so that's it. Instead of substituting 25, I will be carrying the negative again since I did not yet reverse the correct direction. So negative 25 is the ID, simple algebra again. IH will now give us 20 positive, so that means we are correct with our assumption that that is tension. So 20 keeps tension. So now I already know this IH and ID, and then I will now cut this section 2, and then this direction I will be considering that upper right side part. Okay, so this part. So again, that is now not included. So I will just copy that one, of course, to indicate that that is a part of the right side. And now another 30 kips load is included, and at the same time your point H. Okay, so again in here, as we computed that ID or DI is compression, so I will now correct in this figure since this is a new figure. Again, but if you use still a tension, then you should carry the negative. But for me, I will now correct, so I will not be carrying now the negative. And then I will now expose these two members here. If that will be cut, that will be exposed. Okay, I will assume always again a tension. So if that's the case, then I will satisfy again the equilibrium in this section. So I will start by summating vertical. So what are the vertical is this 30 and 15, which are the loads. If I will combine, this one will be 45, and that is going down, so negative. And then of course we have a negative HD that is assumed to be going down, my initial, okay, preliminary assumption. And then this is the only going up, the component of that, which is 3/5 of ID. And the only unknown here is now HD, since we have that ID here. So substitute again, I will not be carrying the negative since I already corrected that one. So 25, and then that is 45, simple algebra, HD will now give us negative 30. It means again negative will be a compression. Okay, so HD or DH is a compression or compressive force. So that should be reversed. But for now, I will not be reversing that one. Okay, I will not be reversing that one yet. I will follow my initial assumption for the next solution here. So, okay, actually you can do summation of horizontal force here. Okay, but since we focus on those two equations of horizontal and vertical, I'd rather include, or I'd rather use right now the moments, so that you will see that we can apply a summation of moments in this method of sections. Okay, but you can still use the summation of horizontal. Okay, if you want, you can solve horizontal. You already know this one, isn't it? You already know that one, and that is the only force that will be giving us a horizontal component, and that will be equated here. You can compute the hg, but again, I will be showing you by using moment. Okay, since I cut this section here, actually this should not be visible, but of course that is still a part of the system. So if I can actually take still a moment with respect to this, even if that is cut. Okay, it's okay, since that is still a part of the whole system. So again, if I will cut this one, and again that is cut that way, so we have this one, this is already invisible, but I can take this one as a point where I will take a moment. Why? Because again, if I will take a moment, look at this, these two members here are connected to that point. So if I will take a moment there, they will be cancelled out. There will be no moment of these two forces, so that I will reduce my equation. So I will take a moment at D. Again, my always assumption is clockwise positive. So what forces will be giving me moments? Okay, not this one, not that one. And so with 30, that will not be giving us moments, since that is passing through the point of reference. So the only force that will be giving us a moment is your 15 and the unknown hg. So clockwise is positive. This will be giving me clockwise. So 15 times, what is the distance according to this? That is 16. 16 each of these. Okay. So 15 times 16, that is a positive moment. And then this hd will give us a counterclockwise, which has a moment arm of 12 feet. So negative hd times 12. So simple algebra again, 20, positive, so it means it is a tension. Okay, so that's it. That is now the new, okay, the new or the difference of method of sections with method of joints. Since in sections you can take a moment at any point, unlike in, of course, in method of what we call this one, joints, we are only satisfying horizontal and vertical equilibrium. So now, okay, we are done with 1, 2, 3, 4. We already know the 4 forces here. Maybe I will proceed now with the next section. I will create the next section, which will be my section 3, 3. Okay, since I already know all of this, isn't it? If I will cut, then I will be exposing two unknown, which is your dg and then dc. I will consider that. The hd, we already saw that one a while ago, which is this one, tension. So that is to be, or going away, since that is tension. So my assumption again for the unknown are all tensions. Okay, so now if I will cut this one, that will expose these forces, and then later on maybe I will be needing this point here, since that will be where the hd and dg will meet, so that if I will take a moment there, this will be cancelled out. So actually that is what I will be using later on. Okay, but for now I will first summate vertical. Okay, summate vertical, which will be giving me vertical is the only unknown member dg, and of course the loadings. So going up, this is going up, component is going up, so 3/5 of dg, and then if I will summate this one, 45 negative, since that is going down, so simple algebra, dg will give us 75, which is positive, so that is tension. Now I will proceed with taking a moment at joint G. Okay, since again I will cancel out these two forces already, so if that's the case, then I will be taking a moment. This will give me clockwise, and this will give me clockwise, and so with this, these are all clockwise moments. So let me start by the moment of DC with a moment arm of 12. Okay, so DC with a moment arm of 12, 30 with a moment arm of 16, so 16 each, and then of course 15 with a moment arm of 16 plus 16, 32. So simple algebra, that will give us a negative 80. So it means it is a compressive force. Your DC is a compressive force, which is 80 kips. By the way, again, as I've said, you can use here actually the summation of horizontal. Maybe actually you can use that one as a way of checking. Okay, as a way of checking. But since I will not be using that one, I will not be doing that one. The checking, I will be doing it once I solve already all of the member forces. But if you want, for okay, for more confident solution or for more confidence answer, you can do that one. You can do the checking, since again there are 3 available equations in each of sections. But if you already use 2, you might have the chance of using the third as the way of checking. So now I will proceed with the next section. Since I already know this one, and all of this, of course, previously, I will cut this way. So this is already known. So this will now be the unknown. So that gives us this CG and CB to be unknown. HG is still positive since I mean tension, since we solved that one to be tension, and DG, we solved that one to be tension. So these are the correct directions. So I will assume that to be tension first. So taking summation of forces vertical, what are the forces? The CG, which is going up, okay, positive. The component of DG, which is also going up, 3/5 of that, and then of course the negative summation of this, which is going down, 45. So substitute what we knew, which is DG, 75, okay, and then CG is the only unknown by algebra, simple algebra. Okay, if we will compute this one, this will give us exactly 0. CG is equal to GC, which is equal to 0. That means this member CG is not carrying any forces, or it is not being stressed. Okay, so this is a 0 member force, your CG or GC. And then proceed by taking a moment at this, at point G. Okay, so that I will cancel out these 3 forces so that I will be having simple equation. But actually you can take moment at any point. So if I will take a moment here, this will be cancelled. So we will be having only a moment of this and this and this. This will all give us a clockwise moments. So positive. So start with CB, moment arm is 12, 30, moment arm is 16, 15, moment arm is 32. So simple algebra again, CB will give us a negative 80, which is a compressive force or compression. So actually if you try to look at this, CB is the same as CD. 80 compression. Why? Because if you try to look at this, if you try, isn't it, going back to the method of joints, take a joint here at C. The only horizontal there are the 2, so they should be equal. And the vertical is only this for the member. There is no vertical force, so that should be a 0 member. Okay, so that is actually a fastest way to solve this one, or fastest way to check or to verify your answer. So now we are good. We already know all of this, so we will proceed. What I will be doing is cut again this one that way. So that will be my section 5. So I will expose, and we already solved this one, isn't it? This force here. Wait, which one? Here, voila. We only solved this force here and that one below. We already know this and that. So if I will cut, this will be the unknown, GB and GF. GB and GF. So we solve your CB to be compression. So I will put the correct direction, which is towards the point. So now, if I will take summation of forces vertical again, so the only force vertical are the loads and of course the component of this, which is going down, negative 3/5 of GB, and negative 30, 15 is 75. So calculating GB is a negative 125, so it means that is compressive force. So now I will take a moment at joint B to cancel out your GB and CB. You will have only GF. This will be clockwise, clockwise, clockwise. That will be counter. So your GF is counter, negative. Moment arm is 12, 30. There are 2 30. The moment arms are 16, and then 32. They are both positive since they are both clockwise. And then 15, the moment arm is 48. So simple algebra again. GF is 180, positive, so tension. And then now summate. Proceed now to the next section. We already knew all of the force within this right side of section 5. So I will cut this way, okay? Look at this. Why did I point the direction of the arrow of this section here? Again, as I've said, if you will consider a section, you can consider the right or left. It doesn't matter, okay? But of course, for simplicity of solution, if I were you, I will consider the part wherein you will have smaller number of forces, or you have lesser forces. Because imagine again, we are summating forces and we are summating moments here. So the lesser the forces available on the system or on our section, of course, the shorter the solution. But you can still use the other side. Okay, since again this is a single system, so cutting at the section and considering the left side, right side, this should be all the same, or this should be all in equilibrium state. Okay, so now instead of pointing the arrow upward, so that I will consider this, okay, since if I will do that, there will be a lot of forces, 1 2 3 4, and then 5 6 7 8 forces. no problem with this. So 1, 2, since we already know that one from section 5. But, okay, again, considering a lot of forces. So I'd rather consider this side, the left side already. So this will be now my section. And of course, I need to carry whatever is present there. And we have here the reactions, okay, that is present there. So I will consider that one. So instead of the loading, that will now be the reaction. So take, again, this is unknown, this is unknown, so I will consider that first to be tension. We solve your GB to be compression, so that should be going towards, and then BC is tension, okay, BC is tension. Let's check that one. BC is tension. Okay, compression. So let me just check this one. Okay, so I just checked the direction of BC, since again, that is we solved that one to be compression. However, actually, it did not affect our solution here, since that is not used, okay, in solving the unknown. So still, but we need to check so that of course you will not be confused. So BC is compressive and BG is compressive, so they will be going towards the joint. And since these are still unknown, I will assume that to be tension. Summation vertical. So let's start with BF, positive, going up, and then the component of BG, which is a negative since that is going down, 3/5. And then of course, what else? This is now the only force that we can see there, the support reaction. 105 going up, so positive. So there are no other vertical forces, so that's it. So substitute what we knew, which is BG, 1 to 5, okay. So substitute and then calculate simple algebra, give us a negative 30, it means it is compressive. So FB or BF is compressive, so this should be going towards, okay. Now I will take a moment at B. So look at this, if I will take a moment at B, BC, BG, and BF will now be cancelled out. You will only have a moment, and so with this, okay, this will be passing to that point, so there is no moment. Only this unknown EF, this EB, and EH. So what are the clockwise here? The EF, which is 12. Okay, moment arm is 12. And then what else? This one, okay, clockwise is still with respect to B. So that is 105 times 16. And then this is a negative, okay, 320 times 12 negative, since that is a counterclockwise. So simple algebra, EF will be positive 180, which is tension. Okay, tension your EF. So now we already know these forces from these members, from this member to this, and this going to the right. So these are the only unknown, the 3 more here. So now I will proceed by cutting to this section. So now I will be considering this section 7. Okay, I will be considering this section 7 here. So I will be considering the left side still. Okay, I will be considering the left side. So this will be the forces. We already solved your EF here from the previous section here. So the only unknown here is EB and AB. Okay, so if I will to take forces vertical, the only force that we will find here is vertical is the 105, which is going up, positive, and the negative component of EB, which is a negative 3/5 EB. So calculating EB, that will give us a positive 175, so that is a tension. And then if I will take, so the only unknown here is AB. So I will not be taking a moment at B, rather I will take a moment at E. Why? To cancel out your EF and AB. Since actually we do not need this, what we need is AB, since that is what we will be solving. So if I will to take a moment at this point E, what are the forces that has a moment are the unknown AB and of course 320. All are passing at that point, the rest are passing at that point, so there are no moments. So we have here counterclockwise of AB, which is negative times the 12 moment arm, and so with 320 times 12. Negative, since that is also counterclockwise. So simple algebra, this will go AB to be negative 320, therefore that is a compression. So now we can proceed. We can proceed now with the section 8. I will consider this now, since the only unknown here is finally your AE. But if I will cut there and consider this side, this will be exposed, and that is AB already solved to be compression. But actually we do not need this, since all I need to do is summate vertical. Okay, and there is nothing for us to summate with your AE. It means that is 0. So 0 force member, there are 2, your AE and your CG, and actually we solved that one using the method of joints. Okay, so now you can use, okay, again, as I've said, just like in method of section, it is always better for us to check. So now I will be considering other section. Okay, I will be considering a different section that I've never considered before. Actually, you can do this section as a way of checking. If you want simpler, then you can use this, since we did not consider this section before. But okay, for us to see that even if I will consider the complicated section, if I will cut somewhere here, exactly on half of that, so considering the up or below, I will still satisfy. I should still satisfy the equilibrium. So if I will cut this way, so I will consider the down part. Okay, so this will be my section 9, just a way of checking. Okay, but you can consider any other section you never used before, you did not use before. Okay, so considering the lowest part or the lower part, what are the forces included? Are this 320 reaction, this member here, the members below. Okay, so this is a zero force member, and so with CG, so there are no directions there. And this BE is tension, we saw that one, to be tension, and this is compression, and this is compression, that is tension, and this is compression and compression. You can go back on the previous slide to check that one. Okay, so now all we need to do is summate moment, summate horizontal, summate vertical forces. That should be satisfied. All of these equations should be satisfied. So I will start by summating. Okay, I will be checking. Okay, this is only for a purpose of checking, since we already know all of the member forces. So summate forces vertical, I will start with that. So what are the forces vertical? Component of BE and DG, these are the going up forces. So 3/5 of your BE and DG, and then going down component of BG and DI, since these are going down with components of 3/5, so negative. And then going down, purely going down BF and DH, so negative, negative. Substitute all of this. So BE is 175, DG is 75, and then of course I will include, so this will now become a negative and negative. So again, I just factor out the 3/5 outside. Simple algebra, guys. So 175, 75, BG is 1 to 5, that is a negative. And then DI is a negative 25. And then negative BF, which is 30, negative DH, which is also 30. So calculate all of these. This will be giving us 0, which is equal on the other side. Supposed to be 0 since we are satisfying equilibrium. So we satisfied equilibrium vertical, so it means we are okay with that. Then we will proceed with horizontal. What are the forces horizontal? This component of this, component of that, component of this, and so with this. So we have 1, 2, 3, 4 components and the reaction. So the reaction is going to the right, so positive, and then the rest, the components of these forces, are all going to the left. So these are all negative. And all the angles or all the slopes are 4/5. So 4/5 of all of these forces, BE, BG, DG, and DI. So substitute 175, 125, 75, 25. Calculating this will give us exactly 0, which is equal on the other side, which is 0. So we also satisfy equilibrium horizontally. Now, the final equation that I need to satisfy is to take a moment at any point I want to. Okay, you can take here, there, here, and there, or even outside the figure. But of course, solution-wise, I'd rather suggest to find a point where there will be a lot of forces to be cancelled. So if I were to take a moment at D or B, he will be cancelling this 3 and that force, or the same thing here, he will be cancelling this 3 and that force. So if I will be doing that, I'd rather choose summation of moment at D. So if I were to take there, then there is no moment of 320, no moment of this 3. So we only have a moment of your BF. And so with this one, okay, you will break this down into components. So the horizontal and the horizontal of that will be having no moment, since that is passing to D. So we will only be having 3 forces with moments. This BF, the component of BE, which is vertical, and the vertical component of BG. So 3/5 of BE, is going up. The vertical is going up, and then the distance is 32. Okay, so that will give us a clockwise, so positive. And then what else? BF. Your BF is purely going down, and that creates a counterclockwise in the moment arm is 32. And the component of BG is still going down, and then the same thing. Component is, the component is 3/5 and the moment arm is 32, counterclockwise, so negative. Substitute, B is 175, BF is 30, BG is 1 to 5. Calculate, that will give us 0, which is exactly on the other side to be 0. So we are 100% sure that our forces, okay, our forces are all correct. So that's it. So again, outline. For us to interpret, it is always better to outline on the figure. So again, just like what we did before. So tension, green is tension, red is compression. So these are the compression force. This one's the red, and then these are zero force members, and the top are the tension. Okay, and again, I explained why the top is the tension and below is compression, because given the loading in these types of supports, this will bend downwards. So you will expect that the top will be under tension, the below will be under compression. So again, even if you will consider this one with our previous result on using the method of sections, joints. Okay, sorry, this is supposed to be method of sections. So that's it, that is supposed to be the method of sections. Okay, I'm sorry, that is just a typo error. This is the result of the section, method of section, which is exactly the same as the method of joints. Okay, so that these are the two methods of analyzing the trusses, but actually you can combine these two. As I've said before, okay, we just try to analyze this purely by method of joints and method of sections, but later on you can combine these two. So actually, how do you combine this? Actually, you can cut somewhere there, that is a method of sections, and considering this joint only, that is already a method of joints already. Sections, method of joints. So actually you can combine these two to analyze the entire. Okay, it is not necessary for you to focus only on sections and for you to focus only on joints. You can combine these two together. Okay, so now let's review some concepts. So for method of sections, we need to satisfy equilibrium in all of the sections. Just like the method of joints, we need to satisfy equilibrium in all of the joints. And of course, consider unused section as way of checking previous solutions. So just like in method of joints, we can use the final joint to check the result. But for this, you can use any section as long as we did not use that one on the previous solution to check, of course, the solution of the previous or the result of your previous solution. So that's it for method of section. So thank you very much for watching. If you have any question, then you can comment that one on the video, or of course you can we can discuss that one on the next live meeting. So thank you very much for watching.